Hello coders, welcome back to my video. So in this video, we will be discussing about the connect system call. What is the use of the connect system call, where we are using, how we are using, how it plays its part in a server client application. So the first thing we need to know about the connect is mostly used in the client program, not in the server program. Okay. So client will be starting the communication by sending the sync of the three-way handshake. Okay. So in the server program, what we have noticed till now, we have list of APIs starting from with socket, then we have bind, then we have listen, then we have accept, then we have send and receive, and last we have close. So this is all we have studied in our last videos. We have studied how these API are linked to the kernel level, what all APIs are being mapped with the kernel and how it communicates. Okay, so let's reiterate what we have discussed till now for our server code. So here is our program which we completed in the previous videos. So first we have the socket system call. Okay, then we have bind, then we have listen, and our server will be waiting on 9090 port. Okay, and local IP. And here we have accept system call, which is accepting from the listen FD and creating a client FD. And we are checking the client FD. If it is less than zero, then we have the error on accept, or we will accept the connection and will be printing the the IP of the connecting socket and the port of the connecting socket. So it will give you details about the client connection, and then it will read and write. So simple as that. This all we have discussed in our last video. So this program is actually a server program. Okay, so we are not using any connect here. So where we are using connect, so that will be in the connect, uh, or you can say the client connect call. Okay, so first of all, let's go to the man page of connect. Okay, so we have man 2 for system calls, and here we'll try for connect. Okay, so first of all, connect will initiate a connection on a socket. So for example, we have a socket that is a server socket and is listening on a port 9090, and we want to connect to that listening socket from the client program. So there we'll use the connect. Okay, and here are the list of header files that we will be using for these APIs to use in our program. And here is our API. So it is connect, then we will input the socket FD, we will input the address and the address length here. So this address is the address where we want to connect, which IP, which port. Okay, so this is for the destination IP and destination port. For example, our server is listening at 9090, so this address will contain 9090 port and the IP. While this file descriptor is the local file descriptor of that client, through which it will send the sync it to the server. Okay. So these three parameters are required for a system call like connect to initiate. So the connect system call connect the socket referred to by the file descriptor to the address specified by the header. Simple as that. So here we are using the sock stream or sock sequence packet. This call attempt to create a connection that is bound to the address specified by the header. Okay, that we have discussed. So generally, what we have seen is for connection-oriented protocols like TCP, we are only connecting the client once, then we continue our communication till it breaks, until we try to reconnect. while in UDP it will try multiple times. Okay, with different association and with different data. Okay, so what is the return value? So the return value will be 0 in case of success, and -1 is returned when there is an error in connect. So what are the errors in connect? So here are the errors. Discuss the important one of the errors. For example, we have E connection diffused. So the connect on the socket stream found no listening on the remote address. For example, we are sending a connect on some IP and port, but that port is not listening. And non, so we'll get this E connection diffused simply. Okay. So if we have timeout, so there is one timeout error. So what it is, for example, the server may be busy to attempt to access the new connection. So at that time, we'll wait for some time before retrying, and then it will try to, create this error, like there is a timeout and we are not able to reach the server. Okay. And also there is EIS connection. The socket is already connected, and if we try to connect it again, then it will throw an error. So it's already connected. So while you are connecting again, okay, until we have an error. And we have ENET unreachable. So if the network cannot find that route, so it will give you this error. Okay. And so let's get back to our program. So let's have a client program now. So earlier we discussed about how the server communicate, and here we have the client. So we start with the first API. So simple as that, we are using a socket system call here. Okay. So we are creating the TCP connection. So we are using the sock stream here as well. And IPv4 connection. So we are using this AF underscore INET in the socket system call, and we are getting a socket FT. So this is the local to this client only. Okay. So we are checking the socket file descriptor. If there is an error, it will return. Okay. And if the socket is created, it will give you this print. Okay. So then next is a server address. So this is the address of our server. So there are two things in this. So first is the family, that could be AF underscore INET, and that is IPv4. Uh, so we are connected to IPv4 address. Okay. And here we have the port. We are converting our ASCII text into binary format. So that's why we are using H10S here to convert in a binary format for this structure. And similarly, we have the server IP. We are converting into this structured format in the binary format so that our network stack can understand this address. Okay. So this API we are using to convert our ASCII to our binary structure format. And if it's got error, then you will get this thing. And if it got success, it will directly go to the connect system call here. So here is the actual magic that will begin. Okay. Here we have this socket FD. Okay. Then we are giving the address of our server, which is listening at certain port. Okay. So here we have the server port as 9090 because our server listening in 9090, and server IP as I'm using a local address. So we are using 127.0.0.1. Simple as that. Okay. So what happened here? So once we call connect, it will send the sync packet to our server, and server will accept it. It will send sync and act to our socket FD, and will return with the acknowledgement, and our TCP handshake is successful. Okay, so after it is successful, we will get this connect to the server with server IP and port. We are displaying it. This will show like your client is connected to the server now, Now we can communicate. So what we are communicate, we have the TX buffer from the client we are sending to the server. We are writing on that socket only. So this is our client socket. We are writing on the client socket, and that is already been connected to the server socket. And where it is connected, in the accept system call, whatever accept is returning in the server, that uh, FD is mapped here, and you are communicating through this FD. And here we are using the send and the buffer, what we are sending, and then we are reading from the client socket whatever we got from that server, and we are printing. Simple as that. So what are the APIs? I reiterate, we have socket API, then we have connect, simple, and then we have write and read and close. So these are all the important APIs that we have in our client. We don't have bind here. Okay. So this is handled by the kernel internally. It will take a random port. Okay. When we are sending this connect, it will map that port to this connect FD. Okay. So that you can communicate properly without any interference with the server. So though it is also, you know, taking some port to communicate with the server socket. Okay. So I think this all is clear. Let's compile both of server and client, and then we'll see what will happen. Okay. So I will take hyphen o server code will have. Okay, and now we have GCC hyphen o client. Okay, so now I will start the server first. So once I start the server, I'll get a message server waiting on the port 9. Okay, and if I need to check our socket, so I have netstat hyphen nalp grep. I will do 9090, and here you will get a TCP socket that is listening at 0.0.0.0, and here we have this server program which we have launched. Okay, and here is a port, so we are going to communicate with this port with our client. Okay, so if I check our client, we already have a client here. So if I run this, you'll see socket created successfully message you are getting, connecting to the socket server 1990 and send hello from TCP client, and we are getting a reply as well, hello client. Okay, so if I go back here, you will see there is a accepting client from this IP and this port. The accepted client have this IP and this port. So this port might got changed when we reconnect it, and we will receive hello from TCP client. And what we are sending from the server, hello client, that we are getting from the server reply. So if I go back and check again, so here you can see you are sending hello client from the server to the client back. And whatever you received from the client, you will be printing here. Okay. And you are communicating through this client FD, which is returned from the accept system call. So this is how the client and the server got communicated like this. Okay. So this is all about a general introduction of using a connect system call. Okay. We'll study more about this socket communication in the next videos. So stay tuned with me. See you in the next video. Thanks.